Technically speaking, technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main. I'm speaking in code when I tech talk that financial freedom. Have a seat cause you gon' wanna sit up at my table, yeah. Plugged in that it, girl, IT with the cables, yeah. Network engineering is for you, it ain't no labels, yeah. Shaky with my passion, took a leap, it got me stable, yeah. Now I make 100K or better, paper couldn't fit a stapler, and I spend it on my passion cause I'm capable. Technically speaking, now I'm really talking vegan when I said that I've been eating, I've been technically speaking. Technically speaking, China white.
Welcome to Technically Speaking, where we help you increase your income through tech. If this video helps you, don't forget to like and subscribe for more ways to boost your tech skills and income. Just a quick introduction to the ones that are new here. My name is Jessica, you can call me Jess, and I am the founder of Technically Speaking. I came from a customer service and a food service worker background, and I broke into tech in 2020 as my first job was a voice network engineer, and it gave me the financial stability I needed. Then I thought, wow, if people could learn tech, they would be able to better their financial situation as well. So here I am. My mission for this lesson is to simplify tech concepts and empower you to succeed. So, welcome back to the channel, everyone. Today, we're diving into some fundamental networking concepts, public versus private IP addresses, the difference between IPv4 and IPv6, subnetting, and more advanced features like virtual IPs and subinterfaces. The goal of this exam topic is for you to confidently explain and compare and contrast public versus private IP addresses. We're going to learn the concepts of subnetting and IP management so you can confidently explain with public and private IP addresses. Public IPs are globally unique and routable on the internet. These are the addresses assigned to devices that need to communicate across the open internet. In contrast, private IPs are used within local networks and are not routable on the internet, meaning they remain internal to your network. Private IP ranges are defined by RFC 1918, including the 10 dot range, 172.16 range, and the 192.16 range. If you can see here, over here. Now, these IPs require a translation mechanism to communicate with public networks, which brings us to the concept of NAT, or Network Address Translation. NAT is what allows private IP addresses to access the internet by mapping them to public IP addresses. There are also PAT, which is Port Address Translation, which allows multiple private IPs to share a single public IP using different port numbers. Next, we'll cover the key differences between IPv4 and IPv6. IPv4 uses a 32-bit address format, providing around 4.3 billion unique addresses. With the increasing number of devices, these addresses are becoming scarce, leading to the development of IPv6. IPv6 uses 128-bit address format, which supports basically unlimited number of addresses. Not only does IPv6 solve the address shortage problem, but it also includes features that improve network efficiency and security. You may have come across APIPA, which is a feature in both V4 and V6 that automatically assigns an address if no DHCP server is available. For V6, EUI-64 is a method of generating addresses from a device's MAC address. IPv6 also introduces new traffic types like unicast, multicast, and anycast. Unicast is the most common, where data is sent from one source to a specific destination. Multicast sends data from one source to multiple recipients who are interested in receiving it. Anycast sends data from one source to the nearest destination. IPv6 eliminates broadcast, which is common in IPv4. Instead, V6 uses link local addresses to communicate within a local network, and the familiar loopback address is represented in IPv6 as 1. IPv4 subnet. Subnetting is a way to divide larger networks into smaller, more manageable pieces. Subnets improve network efficiency and security by logically separating groups of devices. There are two primary methods of subnetting, classful and classless. Classful subnetting follows predefined address classes A, B, C, D, and E, while classless subnetting uses CIDR notation. It creates more of a flexible subnet sizes based on those network needs. You may also encounter VLSM or variable length subnet masking, which allows you to use different subnet masks within the same network. This adds flexibility to how IP addresses are allocated. With IPv6, we see new concepts like tunneling, where IPv6 traffic can be sent over an IPv4 network by encapsulating V6 packets in V4 packets. Another common technique is dual stack, where both IPv4 and IPv6 are run simultaneously on the same devices or networks. IPv6 also uses a shorthand notation to compress its long addresses, which improves readability. IPv6 also introduces SLAAC, or stateless address auto-configuration, which allows devices to automatically configure their own IP address without the need for a DHCP server. Combined with the router advertisements, devices can easily discover and configure their own network settings. Moving to an advanced concept, the virtual IP or VIP is an IP address that isn't tied to a specific device, but is shared by multiple devices for high availability. VIPs are commonly used in load balancing setups to ensure that applications stay available even if a server goes down. Another advanced feature is the use of subinterfaces, which allow a single physical network interface to handle multiple VLANs or IP networks. Subinterfaces are particularly useful in trunking and multi-VLAN configurations. Let's recap what we've covered today. We discussed the difference between public and private IPs, how NAT and PAT enable communication between private networks and the internet, the translation from IPv4 to IPv6, and the different traffic types in IPv6. We also explored subnetting techniques like CIDR and VLSM and looked at advanced features such as VIPs and subinterfaces. If you found this video helpful, don't forget to give it a thumbs up and hit the subscribe button to stay updated with more tech tutorials. And if you have any questions or need any clarification on the topics we discussed, drop a comment below. I love to help. Also, be sure to check the description for more resources and links to related topics. Thank you for watching, and I'll see you in the next video. Keep learning and keep exploring the world of tech.